Okay, everyone, once more with feeling. I'm going to try and talk more clearly. Hopefully all the audio streaming is coming in. Otherwise I'm going to have to redo all my slides. Once more with feeling, we're going to look at the linked list class. Now, last time we talked about this was a while ago, or a couple days ago, depending on if you're me or you, but or maybe a week ago. But the linked list concept, it's this idea that I have a piece of data that points to another piece of data that points to another piece of data that points to another piece of data. That's what we were looking at last time, or some previous time. So I'm going to just use this extra thing. So I have this, and then within there I have a starting point. I have an individual node which points to a node, which points to a node, which points to a node, which eventually points to nothing at all. This is the idea behind a linked list. So I have this data structure and I can store stuff on this, much like a train. I have this starting point that points to the next one, points to the next one, points to the next one, all the way down. And we looked at using a structure for this. And what I ended up doing is I had to keep on passing the linked list in there. And I walked down my linked list, found the place where something is going to be inserted it in there. I'm going to revisit it. I'm going to revisit the linked list class. So let's try this out. So live coding. Let's give this a go. So I'm going to copy all of this just because I'm lazy. So lazy. I'm going to make a brand new project, and I'm going to call it let's empty project. I'm not going to use that. I'm going to go here. In class code. I probably even have a linked list class already. Yes, I do. I'm going to, you know what? I'm going to just make a brand new one. And I might have to get rid of the old one. L07, it's actually 08. Linked list demo new. Just in case you didn't know which one it was, we're going to create a new solution. Hopefully that's going to go fine. All right, I'm going to add a new just CPP file. This is just going to be my main CPP file. LL main. There we go. Okay, I'm going to just add just copy and pasting from my old code. But next, I want to make a brand new class. I'm actually going to make a bunch of brand new classes here because notice I have a structure, which is a LL node. I have a structure, which is my LL data, which I'm not going to really define. And I have a structure called a linked list. So I'm going to make the new linked list class. Hopefully all this is going to go well. I'm not sure if this is going to cause any particular problems, but let's find out the hard way. So I'm going to make a new class called linked list. It's going to have a header file and a CPP file. I'm going to go down to my main. I'm going to start stealing stuff from there. In fact, this linked list class is not going to be all that elaborate. Private. So what is this private? And well, I'll need a new class. So LL node, it's going to be capitalized. So LL node, P start, great. And I'm going to need a brand new LL node class. So let's make a brand new class. New class, LL node, just so we find where things are and I can hook things up. LL node is not going to really do anything at all, but at least the compiler is not going to barf on me. All right, my linked list class points to linked_list.h. My linked list main should also point to linked_list.h, or I should include quote linked_list.h. my linked list.h should have a include ll_node.h. So the linked list needs to know about the linked list node. So I need to include that header file, and I'll include it in my header in this header file. The main also needs to know about linked list. Linked list needs to know about linked list. Linked list node doesn't need to know about linked list. It needs to know about link. It needs to know about. So where is my ll? My linked list node needs to know about linked list.h. So it's what header files do I need to know about? I'll include those at the beginning. All right. Next up, I have this struct. I'm just going to move that struct over to the other part. In fact, I don't even need that struct, which is the kind of quirky thing that I love to point out. Linked list node does not need to, you do not need to know about that struct at all to make all of this work, but we're going to put it in there anyways. Okay, so let's put it outside of this. Okay, so the data itself that's being passed in is going to be of type linked list data. And really it's just a number, because why not? But if I change that, in fact I should probably make that its own class as well. If I change that, I can pass things into this kind of data structure, and it could be anything I want it to be. Okay. My linked list node itself, I need to figure out what those functions I need are, and I need to go through all this stuff. I know that my linked list node class, should have this. So I'm going to go to linked list node.h. I'm going to throw in these private variables, and this is a linked list node. This is linked list data. All right, and that's what every single one of my linked list items needs to have as variables. Those two things. Okay, I need some kind of constructor, and I want some kind of constructor. I'm not going to make a linked list node without some kind of data. It doesn't make any sense for me to have a linked list node without some kind of data in the end. I'm going to have pointers to. I can have pointers to nothing at all, but all my linked list nodes, if I make a node, it has to have some kind of data in it. Okay, so let's save that. Let's go to my main again and get rid of that structure. Linked list, I can get rid of that structure. Okay, here are my functions that I'm going to be using. I have insert at back, insert at front, back, insert at front. I'm going to have remove from front. I'm going to have remove from back. Okay, I got a bunch of these things. In fact, these are all related to my linked list class itself, not the linked list node, but the linked list class itself. I want to be able to go to any linked list, say, give me the front element. Oh, okay, here you are. Give me the last element. Okay, here you are. I want a bunch of variable. So there you go, and I'm going to throw all these in there. So I might want to insert something at the front or insert something at the back. I sure as hell do not need this or this or this or this or this, or I can print the individual. Print node actually is something different. Print linked list is going to be something else. I won't need this one either. The print node, I'm going to put that in my linked list node class. There you go. There you go. Print node. It's just going to print the information about that particular node. Maybe I want something else like get me the next. Oh, that might be something I want. So ll node star get next gets me the next element in my linked list node. I might have a Boolean is end, for example. It tells me if that particular node is the end, the final node. You can't tell if it's a starting node because you don't know if something's pointing to you, but you can tell if you're at the end. Okay. Maybe I want this. So print node is going to be a void, I do believe. All right. Print print linked list. Yeah, that makes sense. I'm going to print out my entire linked list. Walking down this thing. Is the linked list empty? Hey, that's useful as well. Okay, so I'm also going to need to make a brand new linked list from time to time. So linked list is going to take in a grand total of nothing. I would like to point out something else here though. Do I need a destructor? So I want to think about this for a second. If I have a linked list and I'm not allocating new memory, I'm not calling new, I'm not making an array of things, if I'm not doing any of that other stuff, technically I don't need a destructor. If when I delete my linked list I need to clean up everything, then I do need a destructor. So I technically, when I make a blank linked list, it's going to have nothing in it. But when I add an element to the front or add an element to the back, I'm going to be adding stuff to that linked list. I'm going to be calling new. I'm going to make a new node in my linked list and attach it to my linked list. So at some point in time, my linked list is going to call new. If my linked list calls new, I'm going to need a destructor. So I'm going to have a destructor in here. I need to make sure it's there. All right, my constructor and my destructor. Main linked list functions. All right, and then I'm going to go through all these things. Great. I'm going to again be be very lazy, and let's just go grab something. I'm going to make node. That should be in the node class. LL node. I want to see if a make node is in there. Make node is not in there. Do I want make node to be in the make node class? I may not actually even need make node. Okay, let's go back into this. Okay, this before it was allocating a brand new linked list node or a bunch of linked list node, the size of a linked list node times 1. So I'm not going to be doing that. I'm going to be making a brand new node, but I'm going to do this anyways. I don't need a separate function for it, so I'm going to actually just get rid of this thing. Let's figure out insert at front, insert it back, remove at front, remove from back. The same code as I had before. I want to see if the is empty. I'm going to get rid of the LL in there because I don't need it. I'm going to get rid of print. I don't need print node, but I'm going to need the other stuff. All right, and I want to have laziness. Here we go. This is me making a brand new I have a constructor. Tilde linked list. It never takes in any kind of parameters because all I'm doing is trying to clean things up. I have something to deal with adding something to the front. Let's be lazy here and just copy that again, again and again, because I know I'm going to need those 2 colons in there. Remove from front, remove from back, and it is empty. Okay, I don't need that linked list thing here anymore. Okay. And is it empty? I'm seeing if p start is equal to empty. Okay. Insert it back. Insert it front. All right. And then my constructor and destructor. Okay. The start is going to be equal to null. Done. I made a linked list. It's empty. Great. I want for my destructor, I want to check to see if my linked list is if p start. If I have a starting element, what do I need to do? I'm going to need to walk down my linked list, getting the next element in my linked list and deleting it as I go. So I'm going to have some kind of p current is equal to p start. Okay, while p cur, I want to see if this p, well, I want to see if the p current is equal, is pointing to something. Let's find out if I can do that. Let's see this. Is end. While it's not at the end, then I'm going to, so until it's at the end, I'm going to keep on go p cur get next. It's going to give me my next thing, and I'm going to walk down this list. So I need the next node in my array. Okay. Let's do something like that. P2del is equal to p cur. So what am I going to do? I need a pointer to, I need to update my p cur is equal to p cur dot next. All right. So I need a pointer to where I currently am. So I need, if I imagine this, I need a pointer to this thing here. I also need to point to the next thing in my linked list, the next part, and then I'm going to delete the thing, the new, the old, this original one here. So I just move the pointer to the next part, and then rinse and repeat. Okay, so I'm going to delete p2del. If I can just type, okay, p. If I want to be really anal, to del is equal to no. Okay, so I've deleted this. I need to, there's something a little weird about this. You'll see it in action. Standard IO, or let's say IO stream will work. The word null is not defined everywhere. It is a Windows, it can be a specific thing. It's defined in certain places. I could make a definition for it, but otherwise I'll have two duplicate definitions of it. So I could define null if I need to, just by including some of these other libraries that use null everywhere. Okay, so I go down my list so as long as I have a starting point, I'm going to walk down my list and I'm going to check. I'm going to get the next, delete the old, get the next, delete the old, get the next, delete the old, over and over and over again until I get to the end. And when I finally get to the end, if it's at the end, then while p, then I'm going to delete p cur. I'm going to delete the last node. Yeah, the node. Delete the last node, and then I am going to be done with all this. So, and I'm going to be safe. All right, and then I'm going to clean everything up. And that's all my delete method does. I go down my linked list one node at a time, chopping as I go, deleting things as I go, all the way down. Okay, inserting at the front. I need to make a brand new node, and then I'm going to, once I make a brand new node, so let's call it LL node. Let's call it P2add. All right, I'm going to make equals new LL node and to add. That'll make a brand new node. And then what I need to do is, if I have something there, I'm going to then have to find I'm inserting at the front. So I'm going to point this thing that I have, and I'm going to point it to my start, and then I'm going to take my start and point it to the node I just added. No matter what, I'm going to take my start and point it to the node I just added. Okay, inserting at the back. I have this new node here. I'm going to Okay, I make a brand new node. I figure out if I have a starting position. If I do have something already in the linked list, I need to walk down my linked list as I go, and it will be LL node. Okay, I'm going to take my starting position. I'm going to keep on going to the next, to the next, to the next, as long as the next uh, as long as I'm not at the end. As long as I'm not at the end, so I can put a not on the front. As long as I'm not at the end, I'm going to keep on walking down this thing. I'm going to get to the very last position. I'm going to just change the, notice I don't directly access the member variables. I go through a getter method. So I just keep on using these functions versus just directly manipulating the data itself. I call get next, get next, get next, get next. I don't, and the point of this, just to reiterate something, I don't know how get next works. I don't know how things are stored in the nodes. Someone using this system does not need to know. All they need to do is say insert it at the back and it works. If I'm using somebody else's node thing, I don't know how it's implementing the nodes. I don't know if there's 50 different variables in there. I want to just be able to get the next element. Or is it at the end? I want to just query it for the state of the system. I don't care how it's implemented. So I'm going to keep on walking down until I get to the next. And then I'm going to set, we're going to need to set next. That is something I'm going to need to, should be set next, and I'm not sure if it's going to let me. And they set next and the node to add. And the node that I'm adding is going to have a null at the end, so that's fine. So I'm going to get to the very last element. I'm going to set the next to be the node I'm adding, and the node I'm adding is fine. So then I'm done. And then otherwise I need to have, otherwise I have nothing in my linked list, and my start is going to be the node that I'm adding. Okay. Next up, I'm going to remove from the front. So I need to see if this thing is an empty list. If it's an empty linked list, I just return. There's nothing to remove. Nothing is going to be removed. Return false. Okay, I'm going to get the starting position. Linked list node to add. Or start to delete. I'm removing from the front, right? I need to get the next node afterwards. And so I will have get the next. All right, that could be null. And then I'm going to make my start equal to whatever that next one, which could be null. If there's only one element, it points to null, but now my start should be pointing to null. Okay, I then need to free up this data that I just got rid of. So delete p start to delete, and then I'm going to return true. I found the node, the first element of my linked list. I hook everything up so I bypass it, then I delete the node. If I'm removing from the back, I need to keep on checking to see if this thing is empty. If it's empty, I don't return anything. Otherwise, I need to check to see if I have a linked list with a single element on it. So I get the start, so my starting position, and at the, let me see here. If, okay, I don't want that one. I want is end, right? I don't want to know how it's implemented. If it's at the end, meaning my start, there's only one element, then I want to delete p start and make p start equal to null, and I'm done, returning true. Otherwise, I'm going to walk down my linked list until I get to the second last element, then I'm going to delete it. So, okay, and my current node is equal to the starting node. I'm going to get next. So, let me think about this one here. So, I get the starting point. While the get next is not equal to null, I need to also check to see if the one after that is also equal to null. Oh, it will only be, this will only work if I could safely do this one if I only have one element in my array, which is the possibility of this going wrong, right? If this was null, then this would have a problem. But if there was only one element in my array, then I would be stopping at this condition here. Okay, so because I know I have at least two elements in front of me, if not more, I can call get next. I get the next node, and then I get the next node of the next node. Okay, and I want to say, instead of get next, I want to say is end. Well, it's not the end. I just want to be sort of consistent, and I think it's a more intuitive way of describing things. I'm going to get all right, I'm going to keep getting the next to the next, and the next to the next, all the way down until I get to the second last element. So I've gotten down to my second last element by this time. All right, I'm now at the second last element. I want to get the next. I'm going to keep that around, the thing I'm going to delete, and then I'm going to set that to null. I'm going to delete p, the thing I'm going to delete. This is set to null. Okay, and then I'm returning true. I've removed the last element. I want to check to see if this linked list is empty. Okay, so I need to check this thing. So I want to return p start is equal to null. That should actually have been fine. So I want to see what's going on with this code. The linked list has no member is empty. Let's look at this. So what's going on here? Is empty. It says this function doesn't exist. So I'm going to go into my linked list class and see what I have here. Is empty LL. Remember I wanted to get rid of those. Print. I also want print. I'm going to need to implement print. Okay. Okay, and now print my linked list. I'm going to move that over as well. Instead of print LL, I know it's for printing in a linked list. I just call print because I'm saying print for that linked list. There's no need to call print LL and all this kinds of other fancy terms. I also don't need an input parameter. Is if it's empty, the list is empty. Oh, I don't have LL. If empty, is empty, then I print the list is empty. Otherwise, I'm going to get the current, which is going to be equal to p start, and it's going to be a capital LL, because unlike structures, all my classes start with a capital letter. I'm going to call print node on each one of these nodes. I'm going to then get the next node. And then at the very end, I'm going to print n. Okay. Print node has not been defined. This set node has not been defined either. These are the things I have. So print node has not been defined yet. Get node has not been defined. Is end has not been defined. I want to have void set next. That also has not been defined yet. And then ll node n, or next, let's say. Okay, so I'm also going to call another function called set next. All of these things, though, let's go back to my main function. I can go print. I'm going to get rid of print node here and move it over. We're going to have to fix all of this stuff up, but that's fine. I'm going to go to LL node. Oh, I have nothing defined for LL node. Print node. I have this assert thing, so I want to include assert.h because for this. I also need, let's say, let's include IOStream, and let's do, why is that barfing on me? Oh, I'm never going to have it null, so I don't even need to worry about that. I can say cout and n quote, I'm going to say data.num, and that little tilde that I had before. I don't want to do an end line here. I just want to do this one a little bit, and then I'll put it maybe a space afterwards. Okay, so, and I need using namespace standard. So I'm going to use a standard namespace. I'm going to use a cout statement. Unlike printf, I'm just going to use something different just to show you that again. And when I get to the end of this thing, I don't have a, there you go. Get rid of that. Let's see, that's one part. So I've done my print node statement. I need to do the rest of these statements. So let's do, actually I got to do all of these, so I might as well copy them all over. Notice it won't make any difference what order they're done in, which is kind of a nice thing to have. And linked list data itself is, hopefully that's defined in here. Linked list data, so that's pretty good struct. Okay, that's fine. And if, by the way, this is the other reason for the this pointer, and it is pure laziness again. I have a terrible memory. I don't remember anything that I've written or what I've done. I don't remember what I did yesterday. So one of those things that I have is I don't remember my variable names. So if I don't remember, hey, I have autocomplete now. It's nice. If I forget the name of my functions and I'm in my class itself, I can't call like, string dot whatever the case is. This pointer gives me, hey, I have a member variable called data, a member variable called next. I have functions called get next, is end, print node. I want this one. Done. Okay. This is the kind of thing, efficient laziness that I'm trying to encourage with you guys. If I don't know how to do something, if I've forgotten what the member variable name is, this and the arrow, it will give me my autocomplete. I like that. I'm really lazy. Oh, I already did print node, so I didn't need that one. Let's do get next. So I'm just going to copy and paste all these things over. Boom, boom, boom. Okay, I can return next, I do believe. This will be, oh, I don't know if that's a variable name. I don't remember the variable name. This and p next. There you go. I've forgotten the variable name. It gave me an error. I can look it up. Is it at the end? Turn. Am I pointing to null? If I am, I'm at the end. If I'm not, there's another thing. All right, set next. And yes, I should have comments on every single one. Should have comment block here. I do not have time to put those in here while giving a demo, I think you guys would be very bored of me writing an essay on top of each one of these things, telling you what the heck is on it. But you should always have some kind of comment block there. You should know what is going to be next. Okay, so I'm going to say p next is equal to, and this is actually a node. I'm going to set, it should be setting a pointer to a node. It should be called p next for consistency's sake. P next. Okay, so I'm going to set my next each and every time. I'm going to go back over my linked list node, set next, p next. Okay, save it, save everything. Let's see what I have. Do I have any other errors in here? Nothing so far, but I expect errors, right? I'm expecting something's going to go wrong. Why? Because I wrote a whole lot of code just then. Some things happen. That's fine. Let's compile it. Let's see what happens. It's actually going to give me a compile error on the main method. Insert at back identifier not found because it's doing it here, right? I need, what am I going to need? I'm going to need linked list LL. I'm going to, instead of manually setting something like that, I don't want to manually set this thing. I'm going to make a brand new linked list, and then I'm going to make a whole bunch of these linked list data types, a bunch of linked list data, and then I'm going to insert that data in the front of this. I'm going to have to clean all this up. And so I have, the name of my thing is linked list. I'm going to call the insert at front function. For every one of these functions, I'm going to insert, 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 insert. Okay, I can get rid of the passing in a member variable. And it might seem like the same amount of code, but that's besides the point. The point is, how do I want to envision how this works? What at least I think you should be thinking about is, I have a linked list. I say, hey, linked list, add this data item. Hey, linked list, add this. Hey, linked list, remove that. The linked list knows what to do with itself, and you just pass stuff in. That's what I'm ideally looking for in these sorts of things. I don't want to be it's not just some random function where you pass everything into it but the kitchen sink. I want the linked list to insert stuff into itself, versus I have a bunch of data and there's some magic is going to happen when I pass all that data in to this function. Okay, so linked list is empty. I got to get rid of the LL. Fine. Is it empty? I'm asserting it's going to be empty. I insert a bunch of data at the front and the back. I am then going to call linked list.print linked list, and print, sorry. It's just going to print everything out. I don't need to pass in that input parameter. Is it empty? Well, I'm going to say it should not be empty. It's not empty. I'm going to remove things from the back. I don't need to monkey around or mess around with pointers anymore. I say linked list, add something, linked list, add something, linked list, print this. Unlike last time, where it got really convoluted as a result with having to pass in a pointer. The linked list knows how to deal with itself. Linked list print, it's just print, not print linked list. Just print, not print linked list. I'm going to remove some more stuff afterwards. I'm going to print the linked list one more time. And then I would like to do something a little crazy. Not really crazy, but we'll pretend it's crazy because it makes me feel special. We're going to go and put a breakpoint right in my destructor. Why? Because I don't know if this thing is actually going to go off. I want to find out if it goes off. I'm not calling delete in here, right? If I go back to my main method, I make a brand new linked list right here. I never called delete anywhere else. I gotta get rid of this LL here. I never called delete anywhere else afterwards. Will I have a memory leak? did I create all these nodes and then nothing gets destroyed? Or will I somehow magically call delete? So let's have a look at this. When would I call delete? So think about this. If I'm having this right here, I'm not calling new. So do I call delete? Do I get a constructor for free? Or do I not get a constructor for free? The destructor is just for cleanup. Make sure it's for cleanup so we don't have a memory leak. By the way, let's figure out. Oh, there you go. Remove from front is empty. Oh, I got is empty LL everywhere. I cannot directly call get next, so I can call get next. Oh, that is insert at front. I need to set next. Okay, and then here I have print node. I'm going to call print node on the P current node. Okay. I probably also should do a printf cout statement instead of this. Okay. Stupid Google thing. Quote. Just for consistency's sake, I want to use endl instead of using that other stuff. I'm going to use standard namespace. Using namespace std. That is just so I don't have to keep on putting cout, so the std colon everywhere. But I could. I'm going to get rid of this thing. Cout. All right, that will do that. I think that'll do it. Hopefully. Okay, we're going to find out the hard way. So let's see this thing in action. Oh, I got all the way to my destructor. So let's see what happened here. I had 17.2.9.21.0 as my linked list that I added stuff to. I'm thinking it's the same order, but I want to double check that order. Then let's just double check on that order. So where's my main? My data is -2, 17, 9, 21, 0. I add to the front, so I should get 17, -2. Add to the back, so I get 9, 21, 0. So I should have 17, -2, 9, 21, 0. 17, -2, 9, 21, 0. Great. Then I print off the information. I'm proving that it's not empty. I'm then going to remove from the back and then remove from the front. So I'm going to remove the 17 in the first one and the 0. So I should get -2, 9, 21. Oh, -2, 9, 21. Great. I'm now going to remove from the front and remove from the, let me see here, testing code. There's my print off again. Remove from the back, remove from the back. Two more removes from the back. So instead of 2, 9, 21, I should get 2. Great, I got that. And remove from the front, remove from the front. I remove an element from the front. I have nothing left in my linked list. I remove something from the front. Nothing should happen. It returns false, but nothing is removed. It's safety check, right? You can try and remove something from an empty list, you get nothing, right? I cannot, if I give you a 0 on your exam, I can't take off another 5 points. You're at 0 and you keep on staying at 0, right? And then I print off what I have here. And it says the list is empty. Great. And then, what the hell? How am I in this destructor? This is where my breakpoint went off. Where is it getting called? It's getting called right here on this line. At the end of my main method, remember, variables live and die within a function. I made a brand new linked list here, right here, at the very beginning, and at the end of my function, it gets destroyed. Oh shoot, I just closed it off. Sorry about that. I'm right back at my breakpoint. So at the very end of my main method, this gets destroyed. And so now I'm going to take my start, if I have a start. No, I don't. And then I just set the start to equal null, and I'm done. There's nothing more for me to delete. So let's go one more time. I want to test my code a bit more. So let's go one more time, and I'm going to go, instead of this remove from the front business, let's remove some of these things. All right. I also don't need this print. I'm expecting now that I have a whole bunch of nodes that I got to remove, and I want to see that they actually get removed. And I removed my let's try one more time, and let's go to my linked list. And there's my, I got rid of my breakpoint. There we go. So let's put my breakpoint in there to make sure that I'm going to be hitting it. This will only happen if there's something in my linked list and I go through this deleting nodes. I want to make sure that this thing is not going to blow up on my face, right? So let's try one more, and great. I have a starting position. I got a bunch of stuff after the starting position. I have a next, and the next will have a next, which will have a next, and that last next will be null. So I have 1, 2, 3 things that I'm going to be getting rid of, or I should. So I get the thing I'm going to delete. Is it at the end? No, it is not. So okay, then I find the thing I'm going to delete. I get the next item. I delete the thing I'm going to delete. I go to the next. Wait a second. Let me see here. To delete, the current gets moved. Okay, that's fine. I delete the next thing. I should go one more, and I should have nothing else that I could delete. P next. I have a P current. Oh, and then I have one more. I was like, that last node hasn't been deleted. I've only called delete twice, and I should call it 3 times. Oh, here it is. Boom, deleted. And then I bite my start to be equal to null, and then I'm out, and I'm done everything. Okay, this is me completely refactoring linked list, going from structures to objects, and we're going to pick this up again later on when we look at inheritance, when we look at polymorphism, when we look at templates. We're going to keep on going back to this example. So make sure you have a good sense of what we're actually trying to do here. And if you have questions, please ask them in the open or synchronized times. That's what those are there for. Make sure you ask questions. Make sure you ask for clarification. Because quite frankly, I'm just talking into a microphone. I have no idea how many of you are confused. I normally rely on your faces to figure out when someone's confused or not. So please ask questions. Make sure that you're comfortable with this, because if you're not, I guarantee you 20 other people are not comfortable either. And I need to slow things down and give another example or explain it in a different way. That's fine. That's why you pay me. So try and make sure you understand this. And if you don't, please ask questions. All right. When we come back next time, I think we actually are looking at, oh, we're looking at that public private protected thing all over again. All right. With that being said, I'll talk to you guys soon. Stop.